Have you ever been scrolling online and just felt completely lost? Yeah, I'm talking about the world of frequency healing. On one side, you've got these incredible headlines about FDA-approved devices that use frequencies to actually treat cancer. And then, on the other side, you see these machines claiming they can cure, everything under the sun from a distance. It's a lot. It's super confusing. And it really all comes down to this one huge question. Can a frequency actually heal you? The answer, honestly, is kind of complicated. It's a yes and a no. And figuring out the difference between the two, well, that can literally be life-changing.
So on the one hand, you have this legitimate, highly regulated, clinically proven medical technology.
And then on the other hand, you get claims like this, which, let's be real, they sound absolutely amazing, but they just don't have the science to back them up. And that right there, that's the frequency maze we're all trying to navigate.
Okay, so how do we make any sense of this? Well, that's what we're going to do right now. We're going to pull on these threads, untangle this whole mess, and give you a clear map to find your way through it.
To really understand what's happening today, we have to go back to the beginning. We need to look at the origin story that kicked all of this off almost 100 years ago, because it really laid the groundwork for everything that came after. It all started with a guy named Royal Rife back in the 1930s. He had this theory he called the mortal oscillatory rate. And the idea was so elegant, right? What if every single virus, every bacteria, had its own unique resonant frequency? And what if you could just broadcast that frequency and shatter it, just like an opera singer shatters a wine glass? And what's so wild is when you see that core idea evolve over time. You start with Rife's really controversial theory back in the 30s, and then bam, you jump forward nearly a whole century. By 2025, lab studies were confirming that, yeah, electromagnetic fields could actually disrupt cancer cells. And then just a bit later in 2026, the FDA gives its official approval to a device called Optune PACS, which uses something called Tumor Treating Fields for pancreatic cancer. The idea kind of feels the same, but as you're about to see, the science behind it is worlds apart.
And this, right here, is the absolute key difference. Rife's whole theory was about shattering something with a specific vibration. Modern FDA-approved science, it isn't doing that at all. These new devices work by creating an electrical field that physically gets in the way of the proteins that cancer cells need to divide. It's not a musical note, it's more like a physical roadblock for the cell's machinery. Okay, this table just lays out the two different worlds perfectly. On one side, you've got your FDA-approved tech. We're talking Class 3 medical devices that is the highest, strictest level of regulation. They're backed by huge clinical trials with actual humans, and you can only get one with a doctor's prescription. Then on the other side, you have what are often sold as Rife machines. They're totally unregulated, supported by personal stories and maybe some lab studies, and, well, anyone can go buy one online.
So why is this such a big deal? The real danger isn't always the machine itself. It's something called medical distraction. It's the risk of choosing an unproven gadget instead of a validated, effective medical treatment. And when you do that, you can allow a really serious condition to get worse. That is a massive risk.
So we've got the super regulated medical devices on one end and the totally unregulated consumer stuff on the other. But you know what? There's a really fascinating middle ground. Let's talk about a clinical tool that lives in this space. It's called Frequency-Specific Microcurrent, or FSM. Now, FSM is different. It uses these incredibly tiny electrical currents. We're talking about the same level of electricity your own body produces. The idea is to use these microcurrents to target very specific tissues. And it is cleared by the FDA, but for a very specific purpose, as a TENS device for relieving pain. But this is where it gets really, really interesting. Some practitioners are using it for more than just treatment. They're using it as a tool to help with diagnosis. So, how on earth does that work?
It's this clever process they call a trial of therapy. See, a practitioner doesn't just scan the body. Instead, they'll make an educated guess. They might think, this looks like inflammation in this specific nerve. So they'll apply the frequency pair for inflammation right to that spot. And here's the key. At the exact same time, they are physically feeling that tissue with their hands. If that tissue immediately and noticeably softens under their fingers, it's a real-time clue that their hunch was right. It helps confirm that yes, this is an inflammation problem, not something else like old scar tissue. The practitioners I've heard from describe it like using a digital stethoscope. It's not making some magical diagnosis on its own. It's a therapeutic tool that gives them a diagnostic clue. It's all about seeing which key, which frequency, fits the lock of the patient's symptoms. And sometimes that helps them figure out issues that even a big, fancy MRI might have missed. And this ability to provide clues, well, it leads us right into the heart of the confusion that so many people have. So it is time for the showdown. Frequency-specific microcurrent versus that other term you see everywhere, bioresonance.
All right, let's break this down, because the difference is everything. It's all about how they get to a diagnosis. With FSM, a diagnosis is kind of confirmed if the treatment works right then and there. That's the trial of therapy we just talked about. Bioresonance devices, on the other hand, claim they can just scan your body's energy field to find diseases. The mechanism is totally different too. FSM uses a physical microcurrent that causes a real physical response in the tissue. Bioresonance claims it's reading invisible signatures. And that's why FSM is used as a clinical tool for pain, while bioresonance is pretty much considered pseudoscience by mainstream medicine.
If you remember one thing, let it be this. FSM is a therapeutic tool that can provide diagnostic clues. A bioresonance machine is a device that makes direct diagnostic claims, often without any basis in that kind of real-time physical feedback.
Okay, I know, that was a lot to take in. So to help you actually navigate this wild and confusing world, we've boiled everything down into a simple map, a little evidence checklist you can use for any frequency technology you come across.
So here are 4 questions you should always ask yourself. First, is it actually FDA approved as a medical device, or is it being sold as experimental? Second, is the proof from big clinical trials with lots of people, or is it mostly personal stories and testimonials? Third, does it claim to treat one very specific condition, or does it promise to fix everything? And finally, is it something prescribed by a doctor, or can you just buy it yourself online? Seriously, just answering these 4 questions can help you sort the real breakthroughs from wishful thinking.
And all this brings us to one last thought. We are living in this incredible time where physics and biology are starting to merge in ways that are just mind-blowing. And as that continues, the biggest challenge for all of us isn't going to be a lack of options, it's going to be having the wisdom to separate a true medical breakthrough from a deeply held belief. The real question is, how will you tell the difference?